Hello friends. So in this lecture, in this video, I'm going to discuss something called incidence matrix, which is very important even for your university exams and even for your gate examination. You can expect a question, a definite question in university examinations, and you can also expect a 2 marks or 3 marks question, definitely a 2 marks question based on this incidence matrix topic in gate examination. So this video is going to be a bit longer because I don't want to skip a single point on this. So see, first of all, we're going to learn about incidence matrix, right? So the most important segment in the chapter of graph theory is incidence matrix. So first of all, we're going to learn what do you mean by incidence matrix. Okay, what actually incidence matrix means and how can you define an incidence matrix. And next we'll learn how to construct an incidence matrix from a given network. Okay, and next we will learn the properties of incidence matrix, and after that we'll learn what actually is reduced incidence matrix. If you remember, the universal expression to find out number of trees and number of co-trees is determinant of IR into IR transpose, where IR is your reduced incidence matrix, right? So we'll learn what actually is reduced incidence matrix. So without wasting any time, I'm just defining this incidence matrix for you. Okay, see, the complete information related to an electrical network is represented in the form of a matrix, which is nothing but your incidence matrix. See, the complete information related to your electrical network will be hidden in your incidence matrix. Okay, so for example, consider a network. Now the entire network we can also represent in a form of a simple matrix, right? So that matrix is nothing but your incidence matrix. So as I said, the complete information will be hidden in your incidence matrix about the network, right? So what sort of information it is, what kind of information, like what is that information actually, like see, how many number of branches are present in a network and how many number of nodes are present, and between two nodes which branch is connected, and what is the direction of current direction, what is the direction of that current, and like all this information is present in a systematical way, that is incidence matrix. All this sort of information will be present in your incidence matrix. Got it? And with this complete picture of network, that means with this incidence matrix, what do we have? The complete picture of your network, right? The complete picture of your network will be in your hands with the help of this incidence matrix. So without wasting any time, I'll consider the same example. So the first part, so what I said, we'll first discuss about incidence matrix, right? We'll first define incidence matrix. So we have defined incidence matrix here, and the next, how to construct an incidence matrix from a given network, right? So let us construct an incidence matrix first. So from a given network, so first of all, they'll give you a network, right? For that network, you need to draw its equivalent graph. So I'm considering the same example. This is A, this is B, this is C, this is D. This is my equivalent graph for some network. Okay, so I'm mentioning current directions and naming the branches. So this is 4, this is 5, and this is 2, and this will be my 6th. Okay, so we have converted the networks. He has given some network, and that network's equivalent graph is this one. Okay, so I converted equivalent network to its equivalent graph. Okay, equivalent oriented graph it is, because directions are mentioned here. Got it? And see, next we're going to construct incidence matrix from this graph, right? So one important point is incidence matrix is a matrix which is plotted between nodes and branches. Nodes versus branches. Incidence matrix is a matrix which is plotted between nodes and branches. So see, here will be my nodes and here will be my branches. Got it? How many number of branches are present in the graph? 6 branches, right? 1, 2, 3, 4, 5, 6. 6 branches. So I'm 1, this is 2, 3, 4, 5, 6. Horizontally I'm mentioning branches, see? And how many number of nodes are present? A, B, C, D, 4, right? So A and B and C and D. So just differentiate with the lines just to make your life comfortable. So yeah, see, now we need to construct incidence matrix, right? So before constructing an incidence matrix, let us do some small groundwork. Okay, this will help us to reduce the chance of committing a mistake. Okay, so see, let us do some small groundwork. See, this is my node A, right? So what are all the branches associated with node A? Branch 1 is associated with node A. Branch 2 is also associated with node A. Branch 6 is also associated with node A. So I'm just marking them, branch 1 and branch 2 and branch 6. Got it? And what? And what are all the branches associated with node B? 2, 5 and 3, right? So this is 2, 3 and 5. Got it? And what are all the branches associated with node C? 6, 5, 4. So 6, 5 and 4, right? And what are all the branches associated with node D, right? So what are the branches associated with node D? 1, 3, 4, right? So this is my 1, 3 and 4. So now everything is set and you are just one step away. So see, as I said, always consider when current enters the node, consider the current direction as negative. Remember one thing, enters, E-N-T-E-R, right? Spelling of enter is E-N-T-E-R. You please remember like this. Mention N with a capital like this. N means N stands for negative, right? E-N-T-E-R. When current is entering the node, always consider it as negative quantity. When current is leaving the node, always consider it as positive quantity. See here, current is entering the node, right? Current is entering towards node A, right? So this will be my -1. Always remember one thing, if current enters the node, negative. If current leaves the node, positive. That's it. In any case, in the entire networks, always consider the same scenario. Okay, this will be my -1, right? And here current is leaving, right? Current is leaving, so this will be my +1. And same, current is leaving, even in this, current is leaving from node A, right? So this will be my +1. See, now moving on to node B. So current is entering the node B. So entering means this is 5, right? So 5th branch, so this will be my -1. And current is entering even here, right? So at 2 it will be -1. And current is leaving from node B, so at 3 it will be +1, right? And coming to the third node, node C, current through 4th branch, it is entering towards C. So C, 4th one, this will be my, so this will be my -1. And current is leaving, so at 5th branch, so this will be my +1. And current is entering towards node C, so this will be my -1. And same, see here, you can write it for D. I'm just writing there, +1, -1, and this is my +1. I hope you got this, and this is your incidence matrix. So before constructing an incidence matrix, do some groundwork and mark all the nodes which are associated, all the branches which are associated with nodes, and then it is very easy for you to construct. Okay, so this is all this is the procedure to construct an incidence matrix. So let us see. some properties, okay, which very very important properties. So yeah, some properties of incidence matrix. So we have completed two steps, right? First step is what? Defining incidence matrix, and second one is constructing an incidence matrix, right? And next, the third one is we'll discuss some properties of incidence matrix. So the first property is sum of, okay, I'll just dictate here. I'll just dictate the properties, so you please make note them. First property is sum of all the elements in any column is equals to 0. See, sum of all the elements in any column is equals to 0. See, here I have not mentioned +1 or -1, right? So this will be my 0. All these are zeros, okay? I need not to write here because it will make your paper clumsy, so it won't be good if you write zeros here. It won't appear good. So the first property is what? Sum of all the elements in any column is equals to 0. So this is my first column, second column, third column, fourth column, fifth column, sixth column, right? So see, sum of all the elements. This is my element, this is my other element. Here +1 indicates there is a presence of one element. -1 indicates there is a presence of another element. 0 indicates there is absence of elements, right? So +1, do the sum, okay? -1 + 1, 0. And see here, -1 + 1, 0. -1 + 1, 0. -1 + 1, 0. -1 + 1, 0. +1 -1, 0. So what is your first property? Sum of all elements in any column is equals to 0. This resembles something called KCL, right? So sum of currents entering the node is equals to sum of currents leaving the node. See, this is entering current and this is leaving current. When both of them are summed, the output result will be 0, right? All the currents at node is equals to 0. So this is your first property, and from this first property there is one more interesting and unique property. See, what is that? See, in every column there are only two non-zero elements. This is one non-zero element. Non-zero means what? Which is not 0, right? This is one non-zero element and this is another non-zero element. You might think that it is very small element. That is the reason we got two non-zero elements, right? It is very small network. It is very small network. That is the reason we got two non-zero elements here. You might think like that, but it is not the case. Irrespective of the network, always the non-zero elements in a column will be 2. Whether there may be 1,000, 10,000 branches in the network, the non-zero elements gonna be only 2 per column. You please make a note of this point and you please remember this point. The reason is, see, this is my element, a resistor, okay? It is a two-terminal device, right? Two-terminal devices can be connected between two nodes only, right? Two-terminal devices can be connected between two nodes maximum. That is the reason why there will be only two non-zero elements. Between how many nodes you can connect this two-terminal device? Only two nodes, right? So that is the reason you'll have only two non-zero elements. See here, between two nodes you can connect only one element, right? Sorry. So one element will be connected only between two nodes. So for one branch there will be only one element, right? So for branch 1 I have only one element that can be connected between only two nodes maximum. Two nodes are A and D, so that is the reason why A and D, right? So that's all. For a branch there will be only one element and that can be connected only between two nodes. That is the reason why I have only two non-zero elements in any column. So this is important and interesting point you can find out. You can dig from this first property. So first property is sum of all elements in a column is equals to 0, right? So irrespective of size of elements, irrespective of number of nodes, this property also gonna be same. Got it? And now moving on to second property. Yeah, that is what second property is: two non-zero elements per column. Two non-zero elements per column. There will be only two non-zero elements per column. First property is sum of non-zero elements is 0, and second property is there will be only two non-zero elements per column. And the third property is, see, which is very very important. Okay, so I'll just get a paper for you. I don't want to skip to next page. So see, the third property I'll discuss in this paper. So the third property is this one: I minus any one row is equals to IR. See, this is your I. This is your so-called I. I means incidence matrix. So this is your incidence matrix. So what this statement states is, if you delete any one of the row from incidence matrix, it will become reduced incidence matrix. Let us see. See, if we hide or delete any one of the row, can we generate? We can generate the deleted row within no time, right? So what I'm saying is, it doesn't matter even if we delete one row from this incidence matrix. How? See, let us say I'm hiding or I'm deleting the fourth row. Okay, I'm deleting the fourth row here. So I'm completely erasing this. Okay, actually my incidence matrix is this one with 4 nodes and 6 branches. Okay, now I'm deleting or hiding or erasing this branch, this node. Okay, this entire column, entire row I'm deleting. So what can I construct the row without seeing the fourth row? Can I construct the original incidence matrix? Yes, of course. See here, -1 0 0, there should be 2 non-zero elements, right? And summation of those 2 non-zero elements should be 0. And here it is not minus. Here there is -1 and +1 is missing, right? So here there is no possibility of +1. There is no possibility of +1. So obviously here will be +1, right? So I can imagine like that. See, +1 -1. This is 0 and this is gonna be 0 again. This is 0 +1. This is 0. This is gonna be -1. This is 0 0 -1. This is gonna be +1. So 0 -1 +1. Some is 0 already. So here obviously it is 0. So +1 0 -1, and this will be obviously 0. So like that, I hope you understand. See, even if you hide or even if you hide not only D, even if you hide C or even if you hide D or even if you hide A. See, if we hide A, see here, this is +1 0 0, and what is missing? -1, right? So -1 will be here because summation should be 0 and there should be there should be 2 non-zero elements. So this is one non-zero element and another non-zero element which is -1 is missing. So -1 obviously will be here. 0 0 -1, and there will be +1 here. -1 0 0, summation is already 0. So 2 conditions are satisfied, 2 properties are satisfied here. So this will be 0. +1 -1 0 and 0 again. 0 +1 -1, this will be 0 again. 0 -1 0, this will be +1. So like that you can construct the entire incidence matrix even in the absence of one row. That is what I'm saying. See, incidence matrix, any one row is equals to reduced incidence matrix. So see, if we hide or delete any one of the row, we can generate the deleted row within no time, right? Within 10 seconds I can generate entire original incidence matrix. So it means if we are provided with n-1 rows of information, we can absolutely generate nth rows information. See, these are 4 rows, right? If we are provided with 3 rows of information, we can generate that fourth row's information. That is what I'm saying. It means if we are provided with n-1 rows of information, we can in no time we can absolutely generate nth rows of information. Then why to put this information on paper? See, that is what I'm saying. When I can generate the 4th row's information with the help of all these 3 rows information, I need not to write this 4th row's information on paper, right? Because it is wasting my time. It is wasting my paper. It is consuming some space. Instead of writing this 4th row here, I can easily store in my brain, right? Because I don't need this in paper because it is consuming some space. See here, in real time, I'll just tell you real time application. As incidence matrix has complete information about the network, nowadays network analysis is almost done online, right? All those views, multisim, all those network analysis is completely done online, right? Nowadays. So if we delete one row, memory space will be saved. That is why we move to reduced incidence matrix. Okay, this is now reduced incidence matrix, and the fourth and last property is, this is my fourth property. So I incidence matrix is unique. This is my fourth property. Unique in the sense, for one network there will be only one incidence matrix. This is my network, sorry, there is a network, and this is my equivalent graph for that network, and for that network there will be only one incidence matrix. There won't be 2 or 3 incidence matrix for the same network. Okay, so the first property is what? This is my fourth property, right? So the first property is what? Number of non-zero, the summation of elements in a column is equals to 0. And the second property is what? There will be 2 non-zero elements in a column. And the third property is what? Incidence matrix minus any one of the row is your reduced incidence matrix, and you can generate that deleted rows information with the help of the rows present with you, okay, in no time. And the fourth property is incidence matrix is a unique matrix. For one network there will be only one incidence matrix. Okay, this is all for this lecture, and in the coming video we'll solve an example based on incidence matrix. I'll give you one incidence matrix and I'll ask you to draw oriented graph for it. Okay, so in here they have drawn, they have given us what? Graph, and from that graph we have drawn incidence matrix, right? So now they'll be providing us incidence matrix, and from incidence matrix we'll draw its equivalent graph. And I hope you got something in this video, and thanks for watching it with a lot of patience, and please do not hesitate to share the knowledge, and thank you so much for watching the video. Good time to you.